Another major concern for operations is patch management. We've talked before about how important patches are, and I think we can all agree that patches are necessary, and we want to make sure that we have a policies, procedures, and infrastructure in place to manage these patches. It's really important that everything be patched, and in a virtualized environment and in the cloud service environment, that need remains unchanged. We still have to make sure that we have patches and so forth. And one of the things that makes managing virtualized infrastructures and cloud-based infrastructures more difficult is the abstract nature of it, where we can't see it and touch it. There's no physical machine in the data center that we can walk up to, that we can inventory. That inventory becomes a little bit more abstract. Although most of the cloud service providers and the VM hypervisor vendors give us lots of tools to do that, but sometimes it's a little bit harder to understand how that stuff works. But that doesn't change the fact that we have to have a patch management process in place and make sure that all of these different virtual machines are being patched. And virtualization does give us some ability to do automation, whether it's in the cloud or in virtualization. So some of the virtualization products do have the ability to help you manage patch automation, whether it's for the virtualization hypervisor itself or the virtual machines within which are running in the hypervisor. And also the cloud service providers generally have patching infrastructure. So Microsoft Azure, for example, which we use for our lab, you may have noticed that they have tools and they have control panels for configuring how you do patch management in Azure, and they certainly encourage you to make sure that your Windows servers, for example, are always patched. So we can automate the distribution of patches, and again, that can be the same way that we automate patch management in even a physical infrastructure. There is, for example, Active Directory, which is Microsoft's network operating system. We've talked about that before. Does have some patch management capabilities that most organizations seem to be using in most data centers today. So that's certainly a good option, using patch management solutions from vendors like Microsoft. And here's one of the problems with patch management, is that you have the Microsoft patching, which is for the operating system and for the Microsoft products, but there are lots of software and vendors that are outside that microsystem. And then you've got all the open source systems you might be running, like Apache and mail servers and all kinds of other services that may be in your virtualized infrastructure or even in your cloud infrastructure that have to be patched. And again, these challenges are really no different than standard virtualization, um, but one of the challenges is that lack of standardization. There's no one software solution that can manage all patches across the entire enterprise and all of these different environments. And this problem is even more exacerbated with the cloud, because we could have machines running in many different time zones. They could be in many different geographic areas. They could be on many different networks. So it can be difficult to manage those patches across such a sprawling virtual infrastructure. So that can certainly be a challenge as well. And there is, in this slide, you can see at the bottom, there's a little discussion here that I got from the textbook that talks about being able to do patches on suspended virtual machines and snapshotted virtual machines. So there are some tools that allow you to do that as well. So certainly something that we can take advantage of. So patch management, again, it's very important, but there's also a lot of challenges with patch management in the cloud environments that we have to be aware of. We also want to make sure that we're monitoring performance in virtual infrastructure. This is also a part of operations. So with operations management, we want to make sure that we have adequate network, adequate disk, memory, and CPU for our virtual machines, that we don't have virtual machines that seem to be starved for these resources, and that if we find that we can address it. So there are performance monitoring tools, whether we're using virtual environments that are in a private cloud, where we're using something like VMware to manage that, or Hyper-V. They have tools that allow you to do this performance monitoring, to raise those alerts. And there are dashboards in something like Google or Amazon or Azure, where you can monitor your virtual infrastructure, or I should say your cloud-based infrastructure, to make sure that those are not starved for resources, or at least to understand where you're using your resources, to see if you're overutilizing memory or CPU or something like that. And as we talked about before, one of the nice things about the cloud is it's very easy to expand. that infrastructure. But in many cases, there are underlying problems that have to be addressed when we're starved for CPU and memory. For example, and this is one of the problems with the cloud is you could just keep throwing more memory, more disk, more network at nodes in the cloud because you have this sort of limitless, bottomless pit of resources that you can utilize. And just as an anecdote for you, I had a client of mine that I had a process that runs that periodically polls a folder for files that it has to process. So basically, it's a service that was one of the things it does is it checks a file path using a UNC path to a SAN, and it checks to see, or a NAS I should say, because it used SMB or server message block. So it would periodically poll this NAS path, and if it found files, it would process them. So the way I wrote it is it would start, it would poll the directory, and if it didn't find anything, it would poll it again. But if it did find something, it would process whatever it found, and when it was done processing whatever it was doing, it would start right back again and start polling that file again, or that folder. Well, if there was nothing in that folder, the loop would run so fast that it would hit that folder over and over and over again. Well, the operations team for that customer kept seeing the disk I/O. It kept seeing these writes, and it kept seeing it happen so fast. They thought that I needed more performance to handle the writes. They said, okay, he's constantly waiting to read this directory. That's what it appeared as because I was constantly polling it. So they just kept throwing more and more disk I/O at my process until one day they're like, geez, we are giving this application so much of our resources, and it's still exhausting those resources. And they called me up and they said, we don't understand why your application is using all these resources. And I had to explain to them that we don't need those resources. You can meter us. It's okay if we only pull that directory every couple milliseconds instead of every nanosecond, right? So then they realized it and they were able to dial back those resources. But so sometimes it's not as always clear cut as, oh, this server is exhausting resources. Let's just throw more resources at it from an operations perspective. One of the things that, and we talk about this in a lot of different classes, is capturing a baseline. Basically, a baseline is you basically take a virtual machine, or you take your machine that's running in your cloud, and you figure out under normal circumstances with a clean system that I built, under normal circumstances, what does the performance look like? And you capture a baseline. And then what you do is you measure against that baseline in the future. So you're constantly monitoring that CPU usage, that disk usage, the memory usage, all that stuff I was talking about. And when you see it outside the norm, then that could raise a red flag that maybe I should go and check to see why that's happening. It could be happening because of an increase in workflow or an increase in the utilization of those services, but it could also be happening because of some adverse condition, maybe something that's happening that we need to correct. So from an operations perspective, the baseline is a good tool for monitoring and knowing how things should be running, so that we know when things are outside the norm. We know when something's not right. So a baseline can help us do that. So you can do baselines by platform. So Windows, Linux, VMware, they all have tools that you can use for baselining. And certainly Windows has very well understood and documented tools as a commercial product. Linux has tools available as well that are, of course, they're open source, but also, they have very similar tools that you might find in the Windows ecosystem. And then VMware has tools that you can use for baselining as well.